Let's take a look at this example. We are going to start proving this identity from the right side. So let me copy this down first. I have 1 plus tangent alpha over 1 minus tangent alpha. Now, I'm going to copy down 1 plus tangent alpha. I'm going to convert to sine alpha over cosine alpha over 1 minus sine alpha over cosine alpha. Because I have fractions, I'm going to convert 1 to fraction 2. So I'm going to have cosine alpha over cosine alpha plus sine alpha over cosine alpha. Because cosine alpha over cosine alpha is equal 1, and I need cosine alpha because I have cosine alpha in the denominator. I'm supposed to have the common denominator. That's why I have cosine alpha over cosine alpha. Over, again, denominator is cosine alpha, so my 1 is going to be nothing else, just cosine alpha over cosine alpha minus sine alpha over cosine alpha. Now, we can rewrite this as cosine alpha plus sine alpha over cosine alpha over cosine alpha minus sine alpha over cosine alpha. Please notice that we have got two fractions and we have division because the fraction bar represents division. Anytime we divide fractions, we're supposed to copy down the first one and division change to the multiplication and find the reciprocal of the second fraction. This is basically what I'm going to do right now. We have cosine alpha plus sine alpha over cosine alpha times cosine alpha over cosine alpha minus sine alpha. Cosine and cosine will cancel out. Copy down everything whatever left. We have cosine alpha plus sine alpha over cosine alpha minus sine alpha. And someone is going to say, we get to the simplest form, but our right side is not equal to the left. What we're supposed to do next? Next, you're supposed to multiply the denominator and the numerator by the conjugate of the denominator. And we will have cosine alpha plus sine alpha, and I have cosine alpha plus sine alpha in the numerator. Please notice that cosine alpha plus sine alpha over cosine alpha plus sine alpha is equal 1. 1 times this fraction is the same fraction. So the fraction is going to look different, but its value is going to be the same. Next, what we're supposed to do, we're supposed to perform the multiplication. Okay, let me add the parentheses. Okay, and what we are going to have in the numerator? In the numerator, we are going to have nothing else, just the square of the sum. So we have cosine alpha plus sine alpha square. Okay, because we're multiplying cosine alpha plus sine alpha times cosine alpha plus sine alpha. Next, please notice that in the denominator we have nothing else, just the difference of squares. Okay, so this is nothing else just the formula which we used to use. A squared minus b squared is equal a minus b times a plus b, where this is going to be my a and this is my b, this is my a and this is my b. That's why I can rewrite this as cosine square alpha minus sine square alpha. Okay, so what we have got so far. Next, we're supposed to eliminate the parentheses. We're supposed to use the formula for the square of the sum. We have a plus b squared is equal a squared plus 2ab plus b squared. Okay, I'm going to use this formula where this is my a and this is my b. So I have cosine square alpha plus 2 cosine alpha times sine alpha plus sine square alpha over cosine square alpha minus sine square alpha. This is nothing else, just the cosine of twice an angle. So I can rewrite this as cosine 2 alpha. Next, please notice that we have Pythagorean relation. We have cosine square alpha plus sine square alpha. Cosine square alpha plus sine square alpha is equal 1. That's why I'm going to write 1 in the numerator plus 2 cosine alpha times sine alpha. Okay, you can change the order of sine alpha and cosine alpha, and 2 sine alpha times cosine alpha is nothing else, just the sine of twice an angle. That's why I can rewrite this as sine 2 alpha. Everything over cosine 2 alpha. And this is equal 1 over cosine 2 alpha plus sine 2 alpha over cosine 2 alpha equals 1 over cosine 2 alpha is equal secant 2 alpha plus secant 2 alpha over cosine 2 alpha is tangent 2 alpha. Now, please look at this expression and look at our left side of the identity. Now, they are identical. So it means that the left side is equal to the right side.